Good morning, and good to see so many of you here at the Technical Forum. And it's not just the people here, it's also the people online that are watching and later on YouTube. So a warm welcome to you as well. Please have a seat, make yourself comfortable. We have two lovely hostesses walking around serving coffee and drinks on the house. So that's yet another good reason to stay seated here. And another good reason is the talk about to start. Talking about advanced cooling solutions for hydrogen refueling stations and electrolysers. From Lauda, here's the Business Development Manager for Hydrogen. Can I please get a warm applause for Jasper Laug?
Thank you very much for the warm welcome. My name, Jasper Laug, Business Developer of Lauda. I will give you a short overview of our solutions at the whole hydrogen value chain. At first, I will tell you about Lauda, where we are and who we are, and our products in the hydrogen sector, and then about cooling solutions for electrolysers and hydrogen refueling stations. And in the next step, the challenges for the hydrogen cooling systems by the refueling stations, and the outlook, what we are doing in the future, or what we are start with. Lauda is well known for high precise temperatures in all different sectors, pharmaceutical and so on. And we have entities around the world, especially in the headquarters in Germany, and we have another entity with a production in Burgwedel, not far from here, and also in USA, China, and in Spain. That's the headquarters. I'm small enough, I think you can see everything. And we producing here in the gray building on the right, the cooling plants for the hydrogen refueling stations. And we have there 10,000 square meter production site. And we have a total revenue of 120 million, around about 600 employees. And we have, besides the hydrogen, also some focus industries in the biotechnology sector and in the semiconductor sector. And it's a family-owned company, and the regions where we make businesses mainly in Europe and Germany, but also in Asia, America, and Europe. We have products along the whole value chain of the hydrogen production. So we start on the left side with the electrolyzer process. So we have cooling systems, circulation chillers for the electrolysers, especially the PEM electrolysers. Also for the compression and the purification and the drying of the hydrogen. And then on the left, for the refueling stations, so for the hydrogen refueling stations, for the heavy duty and also for the light vehicle. And at least the testing of the fuel cell, so also for high temperatures and environmental testing and so on, it's comparable to the standards of the automotive sector. By the electrolysers, what I already mentioned, so we have the process cooling of the electrolysers with our Lauda ultra-cooled chiller we produce in Spain, and the drying and the purification of the hydrogen, and by the storage, trailer, load, or something like that, we have also our process cooler, Lauda ultra-cool. It's a standalone system. It's also for auto use, and we have a wide range of cooling power from 2.4 kilowatt up to 240 kilowatt. And it depends, you can order this water or air-cooled solution, and with our Lauda Live system, it's a cloud-based system, yes, the possibility for data tracking and analysis and also for maintenance. By the hydrogen refueling stations, we have a cooling plant. It's a big version. You can see it at our booth at B20, but also directly in front of the hall, there is a hydrogen refueling station of Shell. There is one of the first generation. I think it's built up in 2016, and there you can use it you can see it in use. And it's also a standalone system for outdoor use, and it's suitable for passenger cars and also for trucks and heavy-duty applications. You can modularly expandable, so you can connect two SOKs, for example, as well. And you have, with the cloud-based system, Lauda Live, the possibility for remote maintenance. We have a version with, it's conformed to the filling protocol of the SAE J2601, and we have also a system, a black system, no, it's back, for natural refrigerant. Why it's so important to cool the hydrogen? So we have, by the refueling process, always a peak. So that's the cooling power you need for cooling. And we have a delta T of plus 60 degrees down to minus 40 degrees. And when you refuel, then you have a high increase in the cooling power, and also you can compare it to the mass flow. And with our solution, we use an indirect cooling. I will explain it in the next slides. We have the possibility with our plants to only need the average power for our plant. So you reduce the footprint and also the efficiency of the system, and you can bridge long distances as well. By the direct cooling system, you have the evaporator directly in the cooling plant, more or less, and you need the evaporator directly at the dispenser. And with our indirect cooling system, we have a heat transfer fluid. So you have the evaporator on the left side and the heat exchanger only at the dispenser directly with our heat transfer fluid. And with our solution, that's the pump, we have also a cooling storage in the system. What's the advantage? So when you start the refueling process, you buffer with our cooling, with the buffer tank, you buffer the temperature. So you use at first the minus 40 degrees, for example, by a T40 fueling protocol with the cooling, the liquid in the storage tank, and then the cooling process circle is working, and so you cool down by the next step with the recharged buffer tank. What's the advantages and disadvantages? So yeah, the direct cooling is yes, less components. You saw it at the picture or here on the button. It's a simple construction, but it's a very sensitive system, and it's only for short distances possible. And you have to design the plant for the peak power. So you have more or less the double of energy. Our system, the indirect cooling system, is a very robust system, and it's suitable for long distances. And you have the possibility to add a storage tank in our standard solution, and you only have to design it for the average load. And the disadvantages in this case are the additional heat transfer fluid, and you have losses due to the pump. But that depends on the distance and so on. That's the reason why we have our engineers also at the booth to discuss this in the direct contact. And you can also look at our plant directly at the booth without a side plate, so you can look inside, and then I can show you the storage tank in the system. What's the future for us? So we have joined the EU project. It's called READY. It's about the truck load, the refueling of the trucks. So we see that is the most important thing for the future. And there the targets are 100 kilograms in 10 minutes by 700 bar. So it's a very high flow rate with at a peak of 300 grams per second. And that's by the direct cooling, you need the peak power. So we see the numbers there is very high. You need a high energy level here. It starts in this year in February and will end in 2027. And it's based on the previous project. It's called Pride. And there are a lot of partners around the world, around Europe. And that's very good combination to different companies to find a more efficiency solution to refuel the tanks the trucks very fast. And that was the reason why we say, okay, we want to set a standard in the refueling of the trucks and the heavy-duty vehicles. That's the refueling station. There's a small mistake in the picture. I don't know if you find it. But that's directly in front of the hall, so you can see the plant and look, our plant working. It's since 2016 and still working very well. And yeah, you're welcome to visit our booth. It's not far from here. And then I can explain you in detail about our solution and also with our engineers what we can offer and what our expertise in cooling solutions. Thank you very much.